All right. Well, I mean, there's not a whole lot of us. Well, it's not even 8 o'clock. What are we doing here? All right. Well, we'll just. Oh, my camera is not on. Oh, wait a sec. All right. Anyway, we'll wait for a little time. You know, I mean, it's the last week. I mean, last week of formal classes. I mean.
So there's no class on Tuesday or next Thursday?
Well, you know, we're not supposed to. Well, most instructors don't have classes. I'm happy to have a class if you guys want that. I have, yeah. I think, I don't have any appointments that time. You know, I mean, really, if the Thursday is your class final exam, but you know, it's a morning, right? So, yeah, I don't have any commitments at that time. So if you want me to have a class, I'm happy. I mean, it doesn't even have to be about CS2A. You know, you can even ask me questions about 2B, 2C, general CS type questions, any damn question really. You know, it doesn't even have to be CS. So yeah, because it's week 12, we're just going to get together if you want, right? Otherwise, I'll just you know, be doing my own thing. Do you guys want a class next week, or I mean, there's only 4 of you, so you don't have to decide right now. I don't want to put you on the spot, but if you do, you guys have to get together somehow, however you get together, right? Discord or whatever, all of you guys, and decide at least a couple of days earlier, so I can. I don't think it's a big deal, but if you let me know before, I can think up some interesting things to talk about, right? Rather than just get together and like now, I like to get together and have a loose agenda. Right? Up to you. Well, I think this is not Peter, by the way. This is Little Pete. So one of the 2 new guys, and he's really small. And he's just going for all the seeds and nuts first before he eats the apples, I can see. Well, let's see if he shares with this other guy who comes by, Little Ash. And we can start. You know, it's 8 o'clock now, so we're actually formally in class time, but not yet in coding times. We tend to code at 8:15, so we're actually in class time. So you should feel free to ask any questions you have. You know, or you guys can carry on a conversation of your own if you want. That's fine with me too. Yeah. If you want me to disappear, I can step away from the camera and mute myself. That's definitely an option. Let me know. Right, 10 minutes. You know, just. Or if you want me to talk nonsense, or you guys want to talk nonsense, that's fine, okay? But the important thing is to just make sure you don't have silence right now. Is that okay? 15 minutes, because you know this is the time when people are going to join, right? And then when they zoom in, when the Zoom connects and it's just silence, they say, well, okay, I got 5 more minutes because class hasn't started, and so it'll go away, and then someone else might come later, and they don't like overlap. And so there's a perpetual silence because there's always silence and nobody joins. So I think it's important to just keep talking, okay? Somehow, yeah. You know, I can play some random music, but you know that'll sound like a total. Everybody's off right now, yeah. So someone needs to talk.
Professor, so is this class just for us to ask questions?
Yeah, you can ask any question you want. Are you saying you want to ask a question now, or do you want to ask the question next week, or?
Oh, okay.
Yeah. Hey, who is this? You're cutting out. I don't hear everything you say. Can you? Who was speaking before? Sorry.
Yeah.
No, I think whoever it is. I'm going to remove this pen. Wait a second, right? So I can at least lip sync more. I can synchronize the voice with at least the lips. Hang on, view gallery, so I can look at all of you guys. Okay. Great. Now, all right. So yeah, go ahead, ask your question. Now I can look at your lips and I can get a better read. Your audio is like totally cutting out. I can't hear you. Whoever it is.
Hello.
Ray, is that you? I saw your lips move, but that's it.
Yeah,
All right, so now your head is moving too. All right, good. So it's not like you're frozen. Good. So the internet is okay. Can you move your hands like this? Move your hands like this. Okay. Yeah. Okay. All right. So it's not cutting out. It's not cutting out. So I can move this. I can see the smooth. All right. So you got a good internet connection. Your microphone is like I think. Can you say something? Right? Can you say something? A long sentence, right? Not like 2 or 3 words.
Can you hear me? Hello.
Yeah. All right. Yeah. All right. 4 words. Can you hear me? All right. I can hear you, but it was really short. Just be a little louder. Maybe you're speaking away from the microphone or something. Okay. And face the camera. Get to the microphone and speak. Okay. So we're just having a group conversation here. Nobody's trying to run away. Go ahead. Yeah, you're right. You had a question.
It's actually from the module. So can I share my screen?
Totally. Yeah. Why nobody's sharing the screen right now, right? It's a blank screen. So you should just feel free to share your screen. Totally. Yeah, go ahead.
Wait, sorry. I had one quick question. When is the freeze date for the quests?
Rishabh, right, okay. I thought I made this post, maybe it's just for 2C students. Does it say somewhere in the syllabus that if you get to quest number 9, right? If you get to quest number 9, that is working on quest number 9, you don't have to get the password for 2B01, right? If you're working on quest number, meaning that you've got the password to quest number 9 in your hands and you're working on it, then, only then, you get until the Monday of the final, Monday of the week after the finals, which means you can finish your finals on Thursday, right? And then you can continue to polish all of your scores until the Monday, which means that, that week, all your courses are done, right? Every class in Foothill, Dianza too, right? Everything is done by then. The quarter is over. Then you get 3 days of uninterrupted programming, right? You just shut the door, get your bread and butter and say, I'm going to now polish all of my quests. So that's only if you get to quest number 9. If not, your final free state is still the Monday, but the Monday before. Okay, so that's Monday before. So and again, let me make this point again, because some of you are absent. Please pass this message on to everybody else who's not here. If you manage to complete quest number 6, you have passed the class. Okay, definite C+ at least, right? C+. Get to 6, finish 6, quest 6, C+, right there, right? Anything you do over that is just going to boost your grade from there, C+ to A+, right? So quest without stress, if you've gotten to quest 6. Okay, good. What else? And so pass this message on. Most important thing that I wanted to say, especially, right, this is the last week of classes, right? I mean, next week optional, okay, only if you guys want. Anybody who wants to take an F in this class, you're probably thinking, why would I take an F? We had a very, very long discussion last class. There are people who actually want to take an F, right? For various reasons, right? Financial and so on and so forth. If you want to take an F, you got to tell me, right? Because if you think that, oh, well, I've gotten to quest 6, but now if I just top, I'll only get a C+, right? But I really want a better grade in this class. So you say, well, I want to fail. I don't want to take a C+, because if you take a C+, you can do this again. Finish. That's your final, right? C+. So you say, I want to take a fail so I can come back and then get an A+. Then, unless you tell me, you're getting a C+. Okay? If you tell me, I can give you an F there, right? Because you intend to really do well in this class. That's okay. All right. But technically, quest 6, I'm confident. I'm confident that you are, you can pass this class very easily, right? Yeah. I mean, you've already passed, but I'm saying that even if even if the evaluation metric was something else, if you have completed quest 6, you would definitely have passed the class. Does that make sense? I don't know. right? Well, obviously, I mean, all of this is open to correction. You can tell me if you want me to change things around. But I think this, believe it or not, is the result of many iterations of changing the grading things around and changing things every single quarter for the last, I've taught at Foothill for like 5 years now. Right, every quarter there's a small change because students want something, and then we go this side of the pendulum, and this side of the right, and this is what we're here. And I don't know if we're still in the middle, but still, right? If you guys have issues, you got to let me know so that we can tweak it again. I probably won't make this change for summer because it's a contracted class, right? Yeah, everybody has to do this in 6 weeks, but certainly for fall, I'll make those changes, okay, for the new students coming in. All right, are you guys okay with this? So if you, what time is it? I don't know, you guys can still talk, okay? You want me to step off screen? I'll just step off screen for 5 minutes, okay? We'll start coding at 8:15. And then what we can do today is, all right, how about this? 15 minutes. All right, so we start at 8:15. Let's say for 15 minutes, let's just play that game, right? Watch the sorting game that we wrote. Let's just pull it up. It's all ready to go, right? I bet it's ready to go. I don't know who has the code. Who was coding last class? Chanya, was it you who were coding last class? Who was coding last class? This game that we wrote, this sorting game, the final version.
It was me.
Turkey. Yeah. Turkey,
Yeah, I posted it in Reddit.
Okay, good. Yeah. All right. So 15 minutes. Let's play that game. And then after that, we'll start working on pointers. Okay. The most exciting part of CS2A, C++ really, is pointers, right? No other language has it. Right? I say you can have a contrived version of pointers in all other languages, most of the languages, right? So you have this, there's a container, that container holds the location of something that I want to address, right? And you can do that. But C++ you just get raw pointers, native pointers, powerful, bam, like that. Okay, so and it's so cool, right? And we could talk about pointers for hours and hours on end. The beauty of pointers and the power of pointers. But we'll just play with pointers, right? That's even better. The playing with pointers is better than the power of pointers, right? So we'll do that. Oh wow, Turkey, your picture is so sharp now. It's like you're like a 4K picture in that small rectangle that I've got. I don't know what kind of camera you got there, but it's really cool.
Yeah, finally, it worked now.
All right, awesome. Okay, great. So you guys want me to disappear for 5 minutes, and then you guys can talk about what you want to do. 15 minutes, we'll play this game, and then we'll start coding pointers, right? And then we'll start coding a linked list. All right, we'll not your quest number 9, but we'll start sorting some, not linked list, right? Some kind of link structure, right? We'll take we'll create 2 boxes and link one to the other, something like that, right? And then say, how will it do? How can we change that so that if we have an infinite number of boxes and so on, right? All kinds of crazy things. We can do all kinds of really cool things here. So we'll play around with linked data structures today. I bet it's going to be a really, really fun class. Okay, so I'm glad you're able to join today. Hey, David, you're back. Your work schedule changed?
Yeah, I had some morning meetings for a project,
okay,
so
cool,
now
cool.
I'm training up again.
I'm glad you're able to come back, because
Yeah.
this is the last formal week of classes. And next week I will be happy to talk if you guys want to meet. Okay, all right, great. So 5 minutes, I'll just take off, right? And I'll come back in 5 minutes. You guys talk, okay? If I hear silence, I'll come back. Right? If you guys are just talking, go ahead and talk, and then I'll rejoin in 5 minutes, and then we'll play this game. Turkey, you have that game? Yeah, and on your computer?
It's already in Reddit. Everything is posted.
Yeah. Okay. No worries. For 5 minutes, you take your time for 5 minutes. All right. Right. Yeah. Take your time for 5 minutes. How cool is that? Because in New Zealand they have a drink. It's called lemon and peroa, right? And the slogan of that drink is world famous in Peroa, right? So Peroa is a small village-like district in New Zealand, and they have a drink there called lemon and Peroa, and the drink is called world famous in Peroa, right? So like that, you can have all the time you want in the next 5 minutes. You can have any color as long as it's black. All right, talk to you guys in 5 minutes.
So I got here a little late, but we're talking about pointers, right? Okay, this is
Yeah, is anyone on quest 9 right now? Anyone started it yet? Finished. Probably finished, right?
Well, yeah, I finished quest 9 already, but pointers is gonna be really important for quest 9. It's basically the whole thing.
Yeah, I've been on it. I just started it yesterday, and so I'm like halfway done with the quest right now.
I'm still trying to figure out Quest 6. It took me like, oh,
Do you guys have the files? Do you guys have access to the files I posted in the Reddit?
Let me check.
I saw the file on Reddit and saying the in class June 10th. And I got the game.cpp. It's somehow named the void name is display with effect. So is that the one?
Yeah, good catch. That's the wrong one. Let me just double check because I'm still backing up my stuff and pulling them out. And it should be updated now. So do we have any idea of how we're gonna be using the pointers in this game maybe? Or
Well,
does he
for
have
linked
a
list, we're gonna have like it's gonna be like a node, and it's gonna have two parts to it. It's gonna have a data part, and then the pointer pointing to the next node.
Yeah, I feel like for that one, like the hard, like now that I'm like, so basically at the very beginning, just teaching yourself like the whole concept of like the pointer and then, like the heap and the stack and just like how everything's supposed to be. That was the thing that took me the most time. And then, once you like understand it, just writing it, it's like so easy, with all the diagrams and stuff, I think. It's definitely like one of the harder ones, one of the harder concepts I've had to teach myself, I guess.
No, yeah, like the thing that helped me the most was just like drawing out the linked list basically, and then
Yeah.
seeing how like it actually works.
Yeah, definitely. But even then, I was like drawing it. I'm like, yeah, I like got it, and then just like,
Mhm.
oh wait, I forgot to point to this before I reassign. And
No,
it's
yeah,
kind of
yeah,
funny.
yeah.
But yeah, once it's definitely one of the tougher quests. But I guess that's why it's quest 9. So
Yeah.
are you on 2B or have you been coasting?
Oh no, I'm done with Foothill. I'm going
Oh.
to I'm transferring next
Oh.
quarter.
Nice.
Okay, so I'm like on quest 7, but it says that basically it's giving me this error where it's like it says that short, like the short function itself is not a member of STD for some reason, and then like I included the algorithm at the header, and it still is not recognizing it for some reason, and I'm not sure what I'm doing wrong.
Which one's quest 7?
The binary search one.
What'd you say your problem was?
It's not including, like, even if I include the algorithm header, which sort belongs to, it still does not recognize what sort is.
I think we're supposed to create our own sort sort method for that one. I don't think we can use or that was the idea of it.
Yeah, I didn't use sort either.
Yeah, I called my function recursively, or no, not recursively. I don't think you can do it recursively, right?
Mm-mm.
Oh yeah, I forgot that quest.
Let me look it up.
Wait, okay, wait. I'm confused because it never says anything about that. It says that you're just supposed to use the helper method. And no questions
So
asked.
for which mini quest again? The
pet store
binary
one.
shirt 7th.
Yeah, it's a
pet
pet
store.
store one.
So find pet by ID binary.
No, that's not the one. It's like it's issuing an error on the helper methods, which I didn't code up.
Well, you shouldn't be doing anything to the helper methods. You should just
Yeah, I know
copy
exactly,
paste.
exactly that. But it's giving me an error. That's the problem. The helper methods themselves are giving me an error.
So quest 7, right?
Yeah.
Pet store at CPP. And what's the method call that you're having problem with?
Both the sort pets by ID and the sort pets by name, they're giving me an error saying that sort is not part of the not a member of STD.
Oh yeah, you are supposed to use sort. Did you use the standard : and then use sort, or did you just put sort?
Yeah.
Because that's what I have. I'm not sure why.
I mean, like, are we allowed to share screen? Because like,
I don't think so.
Probably not.
my entire code is up, so.
Let's see. So I guess we're not supposed to code.
Because my sort
with
pet by
sort.
ID is really short. Like it's really short.
Yeah, same. It's not.
So where's the error? Is the error in the helper method, or is it when you try to invoke?
You could try submitting it and then showing the error message, and then we could probably read that.
Yeah, I've like submitted it. Here. I can submit it one more time.
I'm pet sort pets by D. Yeah, void pet store sort pets by D.
Yeah, that's a helper method. It shouldn't be making any kind of here. It keeps on. Wait, why did it jump now? It was at 49, line 49 earlier, and then now it's. I'm not even sure if it's like looking at the right one because it's referencing line 61 in my code. It's saying that it's that sort is not a member of STD at
When
line
you're
61.
submitting it, are you submitting all the files?
Yep, I'm submitting petstore.cpp, pet.cpp, petstore.h. It's talking about like some kind of reference pet store for some reason, and that's not even the name of my file.
I think that might be for something for the professor then, because I'm not sure.
Yeah, because it's like throwing that error right now. And then on my line, like line 61 is part of the find pets sequentially by ID, and that doesn't even include sort at all.
Yeah, I think that's you would have to that's a professor then. I'm not
Okay.
sure.
I guess the things that have like gotten me in the past is like accidentally like deleting like a brace or something. I mean, that's the only thing I can think of if you like, didn't modify like the helper methods. There must be something like random that's like missing.
Yeah. No, the thing is, it's not even referencing my
Uh,
CPP.
mm.
Yeah, I think the sort function is given by the professor.
The thing is, it's not even like the odd part is that it's not even referencing it. It's saying ref store.cpp.
Oh, did you submit all the 4 files?
Yep, I submitted everything. It's
Oh,
been
that's-
it didn't generate any output until like 3 or 4 minutes ago, like right before I started speaking up, and then now it's throwing this error when it's not even doing it here. I can send a photo on Reddit.
That's weird.
It's like here, I'll just, I'm not showing my code, but I'm just showing the compiler. Like right here, it's
Member
Pet store.cpp and member function.
Where is
void.
Just a quick guess. Do you include the algorithm in the
Yep, I
header
already
file?
did that. Yep,
I
I
see.
already did that.
What's ref pet store?
I have no idea. If somebody could tell me, that would be awesome.
That uppercase ref, right, is what you're talking about?
Yeah, that uppercase.
That doesn't look familiar to me.
Yeah,
It's gotta be.
It might be
something-
something from the professors on the professor's end then.
yeah, because line 60, on line 61, I don't have any reference to sort. Does anybody know where the professor is?
All right. How are you guys doing? Hey, what is this? You're storing. Are you running Quest code here in class?
No, we're not.
No,
We're just
no.
talking about
All right,
errors.
okay. What's going on here?
Yeah, so basically, like for some reason, it's referencing the
This is my source. Yeah, this is the reference code, right? This is
yeah,
the-
but it's like
your code and then my code, and then we compare the two results. That's essentially what happens in every single Quest. If you haven't figured it
yeah,
out
but
right
it's
now. Yes?
throwing an error on. It's throwing
Yeah.
an
So
error.
why is it not fine? What is it? Sort fetch by ID. Sort is not a member. Why are you calling standard colon sort? I don't think sort is a member of the standard.
No, but it's calling an error on your code, the ref pet store.cpp. It has nothing.
Oh, I see. Oh, maybe it is standard sort then if I call it. But why is it not finding it? No, is there something funky here? Let me take a look. Rishabh, is that you? Did you bring up this issue, Rishabh? Oh,
Yep.
Okay, I was
That's me.
confused for a sec whether it was Chris or you. I'll take a look after. Did you submit with your ID?
Yeah, my ID
Alright.
should be on there. Let me just
All
check.
right. Most likely, I think it is some very simple oversight, probably on your part. But I should have probably, given better instructions on the spec. So I'll take a look at it and get back to you. Is that okay?
Let me add my ID and like submit it one more time.
Yeah. All right. Don't worry about it. Let's step away from this topic for this moment. For the moment. Yeah. Okay. All right. Great. Thanks. So what time is it now? 8:30. We can actually let me. Did you hear that knocking sound? Yeah. Do you?
Yeah.
Yeah.
Yeah. Okay. All right. So I thought it was getting muted. Wait a sec. All right. Okay, great. That's gone. Yeah. So shall we play this game for 5 minutes and then move on? We don't have to play it for a long time. Is it ready to go, Turkey?
Yeah, it is. I found the error. It was the counter and the if function, like in the for loop function. When we had it, it was starting from 1 and equals, smaller than or equals.
Mhm.
But the thing is, the vector itself starts from 0. It doesn't start from
Oh,
1.
I see. It doesn't go.
So this
No, it was a
one is-
corner. It was a corner. We shifted. Instead of going from one to less than or equal to, you went from 0 to less than or equal to.
Yeah, and I just put a 0 there and I fixed it.
Yeah. Okay. All right. So that's fantastic. But are you ready to share your screen, and we can just give this game a whirl? And then it doesn't have to be Turkey. Anyone else who wants to take the screen can take the screen too, because especially since Turkey coded last class. Maybe Rishabh, you don't even turn up for most of these lectures, right? You come once in a while, especially maybe today, you just turned up, right, with this problem. I don't know, maybe if you didn't have that problem, you wouldn't have turned up, right? Nobody's answering you on Reddit, so you decided to come to class and ask. But why don't you take the screen today, right? I'll walk you through it.
I sent multiple emails to you based on why it happened, and
yeah. You're supposed to talk.
Responded, so
I know.
I don't know why I'm getting accused of that.
No, I'm not accusing you, Rishabh, but I'm saying that. First of all, you shouldn't email me about questions that you believe could be generally useful. So I didn't answer you personally because the question could be generally useful to other students also.
Oh, no. It was about like why I wasn't showing up to class. There were 2 or 3 emails sent about that. Sorry. It wasn't about any of the questions.
Oh, I'm so sorry. Yeah, I thought you were talking about classes. I was just joking I was just joking, right? Yeah, I'm not accusing you of being absent intentionally or anything, right?
Okay.
Yeah. All right. I'm sorry. Maybe, some guys just take it too seriously. I should just go more easy on these things. Don't worry.
Well, Anand, if you're deciding someone's grade, maybe they want to make it clear, that,
these kinds of things don't decide your grade anyway, right? So, essentially what I try and do when it comes to grading time is I try to give every person as many points as I can possibly find excuses for. All right. So the only people who really, A plus is out of the question usually, right? Because A plus is someone who basically just A plus is a different kind of beast, right? And I think up to A, I don't care. The only people who don't really make it all the way are people that have taken on too much, right? Like doing like 25 units. I've never done 25, I've never even taught 25 units, I guess, in an account. So, he's taken on too much, or basically just not interested enough to get what's essentially easy. Yeah. All right. So, Turkey, why don't you take the screen? We'll run the code. Yeah.
I'm still going through recovering from my old machine.
All right. Okay. Well, why don't we play that game at the end of class? Is that okay? You can. Yeah. All right. Why don't we just play with pointers now? And then if we have time, we'll play that game at the end. Yeah. Okay. Hey, Rishabh, do you want to take the screen? Are you able to take the screen? You have a pretty decent camera, so I assume you have a decent internet connection.
Yeah, it should be fine. It might turn off in the middle of it, but I can't imagine it would make much of a difference.
Are you like VS Code, or you're going to do it on Replete?
I'm doing it on VS Code.
Yeah. Okay. Cool. Then you already have it all set up, right?
Yeah, I have everything set up. Yep. Should
I start a blank project? We'll start a blank project, and then I can just talk for a few minutes about pointers, and then we'll implement a pointer, right? And we'll implement a pointer, and then we'll start implementing things with pointers in them. That's where things get funny and interesting, right? Because pointers by themselves are interesting, but once you start putting pointers inside of other things, it gets doubly interesting. And then when you start putting pointers inside of pointers, right? Then you're in C++ land. Nobody else can understand you, right? You make C++ jokes that nobody else can understand, right? And in fact, there is a rhyme that I used to hear quite frequently when I was learning C++. This was many, many years ago. I think it used to go, it was in fact not C++, when I was learning C, right? I was learning C a very long time ago. And I think the rhyme was pointers to pointers and printf-like functions. These pointers to pointers and printers. Let me try and remember this. Okay, I think it was like 20 years, right? pointers to pointers and printf-like functions, unary minus and nested conjunctions, integers, booleans, typedefs, and strings. These are a few of my favorite things. All right, I think I've got it. Okay, so I think something like that. Okay, so that was right. And it was really funny. I really loved that. But pointers to pointers is incredible, right? Because once you've mastered pointers to pointers, the universe is basically at your fingertips, because you can point to any damn thing, right? It doesn't matter. And then once you have pointers to pointers, then you basically just go into exponential reachability space, right? Because you can have a 32-bit pointer going in a 32-bit space, but each one of those could essentially be a 64-bit pointer. Okay, right? So, yeah, that's yeah. So we'll do that. Hey, Rishabh, if you're ready, just take the screen. And oh, is that what he meant? It was going to disappear for a bit. Okay. So if any of you have any questions about pointers, sort of what a pointer is basically an address. That's all, right? And it is so simple that people think that, you know, it is so simple that it should be part of every language because it's just an address, right? But the power of C and C++ is that it lets you access the physical memory address of things you store in the computer, right? So if Rishabh was to open a blank project, right, main, a blank project, we'll play around with something, right? We'll create an integer, right? And then create a pointer to an integer, right? And see what the pointer is and what the contents of the pointer is, right? And then we'll create an array and then make a pointer to that. And then we'll increment the pointer and see what happens, and so on. We will try a lot of different experiments, right? And each one of those little experiments is going to have a little nugget about C++ that you can tuck away in your inventory of things that C++ can do, and provided you use them frequently, right? Because you can have a large toolbox with lots and lots of things to do, but then many people don't remember what they have, right? Isn't that right? Even though you may have a large toolbox, and when you have a problem that requires many of these fine-grained tools, if you only use the 2 or 3 most commonly used tools on the top of the toolbox, right, the screwdriver and then a Phillips screwdriver and things like that, what tends to happen is that a certain kind of mental laziness sets in, and then every problem you get, you try and pry it open with your Phillips screwdriver, right? Or you may try a wrong thing there. It'll work, but it'll work in a kind of bad way. And then you get spoiled and thinking, well, I don't have to go deeper in the box. I'll just take what's on top, right? And then you try and make do with what you got and it'll work. And that is the reason 90% of the programs out there in the real world today are so inefficient, right? Because they're not written by true programmers. This is written by people who don't go deep in the toolbox. They just look at the tools that are available and they say they'll make do. And they'll put things together, you know, like a straw hut. And so that's not an engineering solution, right? It is like a kiddo solution, right? Kids that just put things together with Lego blocks, right? To force themselves into place. So, and that is why lots of things work. And I don't know where we're going with that. Yeah, toolbox, right? So you may know about pointers, but it is very important to find problems. You see, that is the thing, right? So lots of people say, I know C++, I've done C++ a lot, but the problem I find is that even though they've been doing C++ a lot, they tend to silo themselves, right? And I think there's a term that we call siloing, right? So silo themselves in the sense they find a niche in C++ or Python or Java. They find a niche that basically works for them, right? It says, well, if I do these things, everything works in this little universe that I have, and it pays my bread and butter, right? And I can take money back and I get vacations, things like that, okay? So I'm happy with just the tools I have, and they don't look any further because it just meets their needs. But unfortunately, that's a problem, right? Because maybe they're doing things very inefficiently, and it's taking up, you know, Murphy's Law, essentially, right? If you try, that is the reason why Murphy's Law works. The reason why what is Murphy's Law? Well, what is Murphy's Law? If something can break, it'll break. Is that Murphy's Law? No, there's another version of it. Yeah, there's an analog of Murphy's Law. I think it goes, available work will always expand to fill available time. All right. So that's really cool, isn't it? And I think that is so true. That is so true, right? So if you give someone like 5 minutes of work and then tell them it's like 5 hours work, they'll make it stretch to 5 hours. And at the end of 5 hours, they'll think I've done 5 hours of work. They won't think I've done 5 minutes of work in 5 hours. Yes? Have you done this experiment? On yourself, not on other people, right? So you think that something is going to take 5 hours, you'll take 5 hours, right? On the other hand, if you think, oh, this is actually pretty easy, right? I should have done that. We actually talked about this last lecture, right? And then you're done with quest 9 in a couple of hours, right? So it is all a matter of mental perspective. I don't know where we're going with that. Time, Murphy's law, right? It just expands. And I think what happens is that it comes into play, and then coupled with this laziness, which plays in a bad way. Not laziness in a good way means that, that is the difference between the two kinds of laziness, I mean, right? The first kind of laziness is I want to just not do anything at all and chill. Okay? So I just want to chill, I just want to be and enjoy what this, everything, right? So that's a good kind of laziness, which means that everything you have to do, you're going to find the most efficient way to do it so you can get done with it and then just be. Yes? All right, so you want to do everything so that you can just, all right, so that is a good kind of laziness because you want to not do anything at all. The other kind of laziness, which I think is bad laziness, is that, well, you know what, I got to do something, but rather than just do it efficiently, I can be lazy about it and do it for 5 hours instead of doing it in 5 minutes, right? How many I have been bitten by that bug so many times in my life. So that is why I know that so intimately, is that when I think that I have a lot of time, I'll just take what I have and expand it. And then, add frills to it here and there. Somehow I'll make it last. And so at the end of the time, I'll come out emerging that I've actually done that many hours. And that's what happens with toolboxes, right? So unless we go exploring, we don't find what's really there that lets us do our job better. So what we're going with all that is that if we get settled into that comfort zone, we stop finding things that will give us time, right? That will let us do what we do better so that we don't do more to fill up the time that we've got. See, that is another mistake that people do, right? What people do is that, I'm doing something in 5 hours. Now, all of a sudden, I've found something remarkable that reduces it to 2 hours, right? Well, what that means, right? Maybe it means, right? But for them, it necessarily means. That's the problem, right? So they say, well, I've got 2 hours of time that I've saved. Now, let me find something else to fill that 2 hours, right? So they're not really taking advantage. So it's that thing, right? So and I think I don't know where we're going then. So if you try and do things more efficiently, and that kind of laziness builds in, and then you try and that's why, right? It's once a comfort zone settles in, you start looking for so that's why I think it's very important for C++ programmers, right? Coming all the way back, right? Coming all the way back is C++ programmers, also Python, any other, right? Is to always continually seek out. You got to actively seek out. If you don't actively seek out a problem that requires you to learn new skills that might also potentially speed up what you're already doing, right? It doesn't always have to be something that's completely new. If it's completely new, I find that people don't have as much motivation, right? So when you have new hires, that's what you find essentially, right? So you can't give them something that's completely new, and most of the time they'll just leave the job, right? So after a little while, because what you have to do is find a careful mix of things they already know and new, right? So they learn the new stuff, not because they have to do the new stuff. They learn the new stuff because it's going to help them do their old stuff better and save them time. That way, when they learn the new stuff to help them do the old stuff better, they'll find the new stuff can help them do the new stuff also, right? So that you get the thing as a byproduct, which is fulfilling to them as well as to you. So that is, kind of the way which you learn eventually. As you start managing more and more talent, one of the ways you'll discover to get better at getting people to do their best, right? Because you never get people to do their best unless they're doing it for themselves. And the only way you can get them to do for themselves is to make it good for them, right? So you can't get them to do something that's only good for you. You got to get them something that's good for them, but also good for you, right? So that you can slowly start showing them this other universe, right? Which they weren't even seeing before because they were totally comfortable in their universe. Yes, I don't know if that makes any sense at all, totally. But I think these are things that a programmer will eventually discover on their own because, 2A, already at the end of 2A, you're nearing the end of your days as a solitary programmer, right? So maybe 2B and 2C, okay, you'll do more on your own. But very soon you're going to start working with other programmers. And then you're going to find that you just don't have the bandwidth. Right, you may have this project, and if you had 200 years, you can do it, right? But you don't have 200 years, so all you need to do now is just find other people who have the same vision, right? You can't just get someone out of the blue and say, all right, this is my vision, and this part of it you work on. It never works, right? So you got to find other people, and so then right, how to work with these other people, and that's how you get these big things done, right? Instead of wasting your bandwidth and cycles fighting with other people, you can get all of them to do the same thing, and then your project reaches fruition much faster. So pointers like that is some people say an esoteric field of C++. No, it is not esoteric at all. It is in fact the thing that we have used all the time, and we use all the time, right? When you ask Google Maps, how do I go to DNA Lounge in San Francisco, right? So it tells you the address, right? So that is the address. You've told it. This is the address, right? Go and figure it out. And we do that all the time. You ask your friend, hey, how do I go to Foothill College, right? 1, 2, 3, 4, 5 El Monte Road, right? It's easy to remember, right? 1, 2, 3, 4, 5. But you ask. You don't say, here's Foothill College, right? So this is the address. We do that all the time. What C++ does is basically just bring that into the programming sphere and say, well, you know what? In C++, you use a lot of things. You use integers, you use characters, you use booleans, everything, objects that you create, pets, games, right? Player, all these are all objects, right? Objects means they're stored somewhere in memory. Yes, they're stored somewhere in memory. No, forget about the fact whether it's stored locally in the stack or heap. We'll talk about all that later, right? If it is an object, it has to be stored in memory. So if it is stored in memory, it has to be stored at a particular location. Yes, whether it's byte number 2 or byte number 25 or byte number 2 trillion, it has to be stored at a particular location. Yes. No, I don't know. Maybe I just put you all to sleep by just blabbering on and on. Nobody's really talking. Everybody looks dazed. Is it too early in the day or what? Pointers. Why don't we pick up the code, right? So, hey, Rishabh, just code. Open up a main, right? Open up a main. We'll just code, and then we'll talk about the pointer. Okay, as we code. Is that better? Are you guys okay with that?
Yeah.
All right. So hey, Rishabh, just create a main standard using namespace standard. Yeah, hash include IO stream. Hash include IO stream. No. Why is it? Hey,
I haven't made a CPP file.
Oh, just rename it. Rename it to pointer experiments. Pointer experiments.cpp. Pointer experiments.cpp. Yeah. Yeah, pointer experiment.cpp. That's fine.
Sorry. Yeah.
Yeah, it's fine. That's fine. Yeah. All right. Just why is it? Yeah. All right. Great. Hash include CPP. I know hash include IO stream. Because we'll be doing IO stream.
Hey, I can just pull up my old code and like just do it from there.
No, don't. We're gonna
okay, sorry.
Yeah, from scratch. Dismiss that window VS Code thing, so you get the whole thing.
Yeah, sorry. Yeah, let me just delete this part. Sorry.
No, I can read it. That's fine. Yeah, this is a panel. Now your screen is too big. You need to.
Yeah, sorry.
No,
I'm like only sharing my
left screen is gone. Left of the screen is gone. All right, this is good. Just leave it like that. Yeah, I can read it. Everybody okay with this?
Yeah.
All right. So yeah, blank line and use namespace standard, and then open up a main, int main, return 0, and then we'll fill in the body of main. Right. I'm going to do some experiments here. And here, what I'll do is rather than call out individual lines of code, Rishabh, and you should tell me if this is okay. I think we did this last class with, was it you, Ray? Someone else. You can tell me if this works. Otherwise, we'll switch back. I'm not going to call out the actual lines of code. I'll just say what needs to be done. I think it was Chris maybe, right? Let's say what needs to be done, and then you can type it in. Yeah, using your own way of doing it. Is that okay? Great, okay. So int main, what we want is we want an integer variable. You can call it something you want, right? Call it anything you want. We just want an integer variable.
What is the purpose of the integer value? Sorry.
We just want an integer variable. What we want to do is assign it a value, and then we want to print the value of the variable. We want to print where it is stored in memory, right? The address of the variable. All right, and then we want to do a few things. We want to create a pointer that is the same as that memory location, and so on and so forth. Okay, we're going to do all those cool things. Does that make sense? Oh, yeah. That's why you wanted to know what the thing was. No, don't call it memory address, right? Not yet. We're going to do that. For now, don't do that. You just say int, just your variable, just an integer variable. Yeah, just call it. Yeah, you can assign it some value if you want. All right, great. Now on the next, well, now see out the line. See out with a tag, right? See out my int var equals, and then you can say. You put that in a tag within quotes. Yeah. Put that within a tag. You know, every cout statement. This is a really good tip. Okay, as you're getting, as you're starting to face question number 7, binary search and all. Yeah. Okay. A really good tip to have is anytime you write to standard output cout, right? Tag it, because pretty soon debugging. One of the best debuggers is cout, right? Because many times. You have a 99% clue, suspicion what's going on. The hassle, the mental hassle of firing it up and setting a breakpoint and debugger, too much for you. You know what your suspicion is. The light ray should bend over the sun, and you say, this is my prediction. This is what is going to happen, and the prediction is I'm just going to put a cout right there, and I bet the cout is going to print this value. Right? Right? That is your scientific prediction, and so always put a tag there. You'll have so many of those. Very soon you'll have 10 or 15 of those in your program at some point. And the other thing I do is also when I do something like that's called a debug statement, what I do is also tag that line with 4 forward slashes at the end. You don't have to do it this way. At the end of the line, put 4 forward slashes at the end of that line. How you want to do that? What's JTS CD? Oh, JT is JT dollar.
Oh, I'm just compiling it right now, just so that
that's how you compile it in VS Code.
Yeah, that's how you
got a button. You haven't bound the button to something. There's no triangle. Click that triangle. It should automatically build.
Okay, I can do it with triangle. Okay. Yeah.
Did it run?
Yeah, it ran.
Oh, it printed the value 4. Okay. Yeah. All right. Cool. That's great. All right. Good. Now, is everybody on steps on the same page so far, right?
Yeah.
Good. Okay, next step. What we want to do is we want to create a variable that is not this variable, but it is in fact, it is a variable that points to this variable. In other words, that is a variable that tells you where this variable is stored in memory, okay? And that kind of variable is called a pointer, okay? And we declare it on the next line. On the next line, we say, no, after the int var equals 4, hit an enter after, and by the way, 4 is not a random number, right? It is, it's not a random number, right? So it's some number, say some number, right? Not random, because random has a different connotation to us, right? Some number.
And you need the asterisk before the name of the variable, name of the
Yeah.
Int star pointer equal, int
star memory pointer.
Int star and then memory pointer.
Not here, yeah.
Int
line
space.
5.
Not there. The next no, next line.
Yeah, line 5 in front of the memory pointer. Not here. Here is okay.
There is okay, but I have a convention and a habit of putting the star, not stick it with the int, but stick it with the variable. And the reason for that is that variable is not of type int star, because if you have another variable on the same line, which is just a plain integer, people will tend to mistake it by saying, well, that's a pointer and that's also a pointer because the first word is int star. That's wrong, right? Highly misleading. So attach the star to the variable, not to the int. Does that make sense? Right? But you'll still see as you go out and code, even on Stack Overflow and all these other public sites, you'll still see a lot of code in which the star is on this side. All right, and people do that. but this is the reason why I don't do that. Okay, so. All right, now what we want to do is we say ampersand int underscore var, okay? Int underscore var, and hit an enter after that, because we always want to separate the logic from the initialization, right? The first two are initial, all right, the next, right. Now, what that means is you can put a comment there that says, now memory pointer is, this is the play is equal to the memory, is equal to the memory address where int var is stored. Okay, that's going to be too much to type on one line, right? I don't know how you're going to do that, right? Maybe put it on 2 lines, or maybe change the, you know, your variables to something shorter, like not memory underscore pointer.
So memory pointer just basically holds the address of int var, right?
Memory
Yeah.
pointer is the address, exactly. Yes. Was that you, Chris?
Yeah.
Is it basically copying over the address, or is that not the right terminology?
No. All right, type this in. Right? Say,
It's not copy.
and also this should go before the memory point. Also, you're getting rid of the blank line. Always keep the blank line between the logic and the declarations, right? As much as possible. Sometimes you're not able to do that, but as long as, no, yeah. Next line, have it. All right. Now, this comment should be on the same line. What we should do is, let's try and say what we did more succinctly. If someone can come up with a way, tell us. All right, this may, make memory pointer equal to address of equal to, no, you can actually say equal to, because, you know, everybody's saying it knows what equal the letter equals to is, right? I think save you space on the line, equal to address of int var, int underscore var. No, not double equals is a comparison, right?
Yeah, but I mean, like,
equals-
that's just like, because people might like think of it as a typo. This will like just make it like,
Oh, I see. Okay, all right. Int var.
yeah.
All right. So now, how do we know? Now, what we'll do is on the next year. No. Don't get rid of the back. You have to get rid of the habit. Hey, Rishabh. So you have to break that habit. You see that blank line. I think you have a tendency to delete it, right? Keep it there. Otherwise, it'll save you many milliseconds. All right, that will add up. Yeah.
Okay, got it.
Yes. Okay.
Yeah,
On the next
make it
line. On the next line, copy and triple click on the line and triple click on the line. No, triple click. Right. No, not 3, not 4. 3 clicks. 3. All right. No. All right. Now hit Command C once. No. All right. Now I want to try this once. Okay. I want to try this. Get rid of that Command Z out of it. I want to try this. Okay. Yeah. All right. Triple click once. Now don't do anything else. No. Yeah. All right. Don't do anything else. Hit Command V. You hit Command V. Now hit Command V one more time. Okay, all right. Now, so without doing anything at all, it pastes in the right location, right? Okay. So what happens is that I find that, especially in 2A, right? When you want to, triple click is really powerful, right? Because if you do triple click, it saves you many milliseconds. Because if you don't do triple click, then you waste a few milliseconds in getting to the right column. Okay. It's very useful to remember. And also this blank line. All these things speed you up really much, right? So keep that in mind. Now change that int var to memory. Yeah, okay. Memory pointer. Yes. In fact, we can say something even better, right? Write that there. And then instead of saying memory pointer is, you say it is stored at memory location, right? Instead of the memory pointer is, say it is stored at memory location. It is stored at memory location. Let's run this and see what happens, right? Yeah, print that. There's probably a hotkey for that too, right? You don't have to type it in the console, but I think there's also a hotkey. Not just don't have to use a mouse. I think there's a Command B or Command K, something like that, which is same as the triangle.
I think it's not Command S. I think it's F and F5 maybe.
Oh, this is a Windows machine?
No, I think that's just how it works with Python. But
okay, all right, cool. All right, good. That'll also save you time. int var is 4. Now look at that, okay? Now looking at this, there's a lot of information, right? There's a lot of information that can be uncovered by hackers who look at your log files, right? If a hacker looks at your log file, they can tell a lot of things about your machine and how, sometimes even, stuff that you don't want to expose is in your log file. So in this case, it's kind of benign because we look at that and say, right, I'm gonna have to increase the size of the font. Hang on just a sec. I'll just zoom in. Wait. All right, so now I know this machine is running on 7FFE, 7FFE E326554C. Okay, that's that's 8 times 6, 48. All right, maybe there's 2 leading zeros. I know that's the address, and that's the memory address. This is a 64-bit machine. Okay, it's a 64-bit. If it was 32 bits, then you only have 8. The 32 bits means that the address of any byte can only be stored in a pointer that is at most 32 bits. 32 bits means 4 bytes, right? 4 bytes, which means that the maximum addressable space on that computer in a 32-bit machine is 2 to the 32. Right, assuming you don't have negative addresses, which you don't, right? 0 to 2 to the 32. Now 2 to the 32 is 4 billion, right? 4 billion is 4 gigabytes. So if you have a machine which is 32 bits, the biggest pointer you can address on that machine is 4 gigabytes away from your root node, which is location 0. Now you know why in ancient versions of Windows, Microsoft Windows, the biggest the biggest data structure you can have, the file event, right? File or things like that. 32-bit machine, the biggest number you can represent really memory location is 4 gig, right? If you have memory more than 4 gig, you can't access that in 32-bit address space, right? You have to go to 64-bit. And this is a 64-bit machine, and you can look at the address. The address, just by the pointer, you can count the number. I don't know. It's 64 bits, meaning 8 bytes, right? 8 bytes, and each byte has two hexadecimal digits, right? Each byte is 2 hexadecimal digits, right? So it's 16 hexadecimal digits. So in this, we don't count 16 decimals, right? So what that means is that when Rishabh ran his code, okay, it got allocated to something it didn't even go to the top of the heap, right? Top of the heap is big numbers, right? When you're nearing like close to, I don't know, let's say 64-bit is 2 to the 64, a large amount of memory, right? So when you're in the upper ranges, here we're still in the lower ranges of his memory, which means that this is a machine that has been booted up recently. You can tell a lot of these things just by looking at the memory address and where this program and what kind of program it is. So hackers know all these things, right? Hackers know all of this in very much great detail. Now, looking at that one line, they probably know like 100 times more things about Rishabh's computer than I did just now, right? So those are interesting. Now, but what I mean is that now we have 2 important pieces of information surfaced to us. One is the actual value of the variable. And the other is a place where the variable is stored. Now, if a hacker knows that, right? Here's the cool thing. If a hacker knows that, and they can weasel their way into your computer's memory through a virus, right? And they know that your, int var. Int var is stored at that 7F, I don't know, let's call it location Joey, okay? So some location Joey, right, in memory. Now, they don't even know about your program. The only thing they know is that from your log file, you have a variable that is stored in location Joey, right? So all they need to do is have a virus that somehow weasels itself into that machine and then scribble something into that location, right? They don't even have to go to your program anymore. They just need to go and scribble something into that location, change that value, and then your program tries to read that value, it's going to get a completely different value. Yes or no? Okay, so we'll try and do that now. All right, now on the next line after that, see out, hit and enter. Yeah, break that up into 2 lines. It looks kind of ugly. Yeah, with no, it shouldn't print that number. Who knows? This particular time it stored that number at that location. Yes, Rishabh? Right, I want to clarify this. Yeah, it's a common mistake, right? Many people could make that. So look at Rishabh's comment there. Hey, put that comment on the, make the comment on its own line. Maybe put it on the line before that. Okay. In fact, should print 4. Hit and enter after that. Put hit and enter after should print 4. On line 7, go to the end of line 7. End of line 7. Yeah, enter. Okay, all right. Now take that, one more enter. Okay, now take that entire comment you have on line 10, right? Yeah, put that on the line above that, right? Right now, should print. No, it shouldn't. Right. So I want to call our attention to what Rishabh wrote there, which is very common, right? It says it should print this address. Yes, but every time Rishabh's program is run, I don't have any guarantee. That's where this memory address is going to be. Next time you run it again. I bet you'll get a different number. Okay. Now, what does it end in? It ends in 6554. Run again. I bet you'll get a different number. Yeah. Okay.
Yeah.
Why is that? And the reason is that when you run the program, it's until you run the program, your program is basically in crypto mode, right? Not cryo mode. Okay, it's sleeping, right? It hasn't been kissed by Sleeping Beauty, that prince, right? It's just sleeping right there, right? Now, when you run it, then your CPU is going to say, well, now I got to run this guy. Let me find some location in memory where I can fit this person, and then tell that code to run. Okay, that's when it's actually going to look to see where can I fit this in memory. Until I fit it in memory, I can't run. Okay, it'll find some place in memory to run it. Now, if your computer has just been booted up, yes, this is where I was going before, and it's all fresh and clean, it'll probably find some memory in very low new space, right? Zero in the first 5,000 bytes or something like that, right? Bam, it's right there. Now, if your computer has been on for a long time and it's running some big ass programs like 5 Chromes in the background, okay, right? Now, when you ask it for like 10 bytes of memory, it's going to allocate some 10 bytes of memory very high up somewhere, right? Because all the low space has been used up by these programs, it hasn't been recompacted and stuff like that. Now, right? It's gonna, I think so. This is my hypothesis anyway. I don't know, right? So next time you run it, who knows where it's going to be? It's going to be somewhere else. That's the beauty of it. You don't need to know, right? The logic of it, and see, that is a power. That is a power of the program, is that you don't need to know where the variable is stored, as long as you're happy with the variable doing its job wherever it's stored. You're okay with it. Yes. Yes, it's the exact quality that makes you a fantastic manager eventually, right? When you start managing talent and resources, what is it that makes us a good manager? I don't know where we're going that. The variable. What were we talking about? Memory. Yeah, location, right? So all you want to do is, I want to write a program which has no dependencies. Right? I want to hire people that I don't need to know anything about them. I don't need to know how they live their life. I don't need to know what they believe. Right? All I need to know is that if they are aligned with the same vision, that's all I need to know. Right? Everybody should be free to do whatever they want, believe whatever they want. Right? As long as they're aligned with the same vision, we'll achieve that. And that's the only thing that matters. And we say my program is going to be such that this particular value. It's not that my program is going to work only if this variable is stored in that location. Then that program is not going to work at all. Well, it will work, but it'll work only in your home, on that computer, on that particular day, that particular minute, and that particular invocation works, right? Because you have it in that location. Otherwise, it's gone, right? So and so now we've printed value. Now let's go and try and sneakily in this program, right? In this program, change the value of that variable to something else, and then print it again and see that it's changed. Okay, so. A what does it say? Heavily loaded program will have. No. Hey, Rishabh, I'm very scared to say these things because you're typing it in, because it may not be right. Many of these things I'm just pulling out of thin air. Right? It's up to you to verify and find out. Yeah. I'm sorry. You should only accept what I say that makes sense. Okay. And what things doubtful, you got to go and check it out. So I don't know if this is true, whether it's high space, low space, maybe the memory manager works completely differently, right? I'm saying that if I were to design something, right, with some stupid ass guesses, if I were to design something, it's my first iteration, that's what I do. And maybe after a lot of research, I find out, no, that's not how it should be organized. So yeah, you should not take my word for these things. Get rid of those lines. I'm sorry. I don't want it to confuse other students because it's going to be recorded, right? So I don't want to, not that anybody watches these videos, but at the same time, yeah, get rid of that. Should not print 4. What it should say is, no, of course it should not print 4. What we should say is print the physical memory location at which 4 is stored in that variable. That's what it should say. Print the physical, get rid of should not print 4 because that's obvious, right? So let's say print physical memory location where 4 is stored inside of, or in brackets, you can say, address of, the address of int var, the address of int var. I think that would be cool. Yeah, okay, I think that's cool. Is everybody okay with this so far? That's nice, that's nice. Okay, now let's go and say, all right, so on the next line, blank line there, I'm sorry, blank line. Let's all do it in chunks so that every chunk people can look at and say, okay, that's what we were trying to learn there. That's what we're trying, right? So each one of these is just 2 lines, but it actually encodes a greatly important thing about C++, right? It's just 2 lines, but it is worth meditating on those 2 lines just for a little while to see what is it that those 2 lines we're trying to, what is it that we're experimenting there to find out, right? And it takes a little while. But when you say, well, thinking back to the class, this is what we're experimenting, and this is what we're trying to do, and then the power. And when you know the power, that you can, you have less effort in, pulling these tools out of. Otherwise, that's what I was saying, right? Otherwise, people will tend not to use pointers. Right. This is where we're going. Using pointers and these skills is a useful skill to have, but it's deep down in the box. And the problem with many self-styled programmers is that they can do their job. Anybody, they can do their job without having to do these, use these pointers, right? They can do it. And the problem is that because they are not comfortable with it, right? The thing is, and it's a tragedy, right? Because if they got comfortable with it, if someone in 2A had pushed them, right, and said, you're not going to pass 2A until you master this, right? And they master it somehow, right? Then they'll know that I can use that and gives you a great, but otherwise, because it's so uncomfortable, they would not even do that. And that's why this is a great time. This is a great time to play with pointers and actively seek out problems in which you're forced somehow, right? You're forced to use pointers because you can always find problems that don't require you to use pointers. And in C++, the only way to get around that is you have to go out of your way sometimes, right? Go on trails on which you may find some dangerous beasts, not just harmless birds, right? You got to find them.
Hi, I have a question.
The
2 new lines, it doesn't make sense.
What 2 new lines don't make sense?
Yeah, the last 2 lines. This will copy over the actual memory pointer.
No. I'm sorry. Wait.
Oh wait, this is my own.
No, we're going to change this. We're going to change this. We're going to change this. Change the comment. That line. Change the comment. We're going to say sneakily change the value of int var without assigning something to it. Right? Sneakily change the value of int var without actually assigning to it.
Wait, we're not doing that though. It's.
No, we're going to do that. We're going to do that on the next line. We're going to do that on the next line.
Okay. Just
right. Sneakily. Right, type that in because if someone reads that, they'll know exactly what we're trying to do, right? Sneakily change the value of int var without explicitly assigning to it.
I mean the
assigning to it.
Sorry, this one, like, I think he's confused about this one. Basically, I just wrote this just
to differentiate
between those two because I know, like, if I'm going over this notes afterwards.
I see. No. All right. So thank you, Hao-Yan. I didn't even see that line before. Okay.
I didn't only print 4.
I got that. It's not copy over. What Rishabh was trying to do was try and make this program, and Rishabh, correct me if I'm wrong, try and make this program step-by-step document so that, every line captures something that we're talking about so that we can just follow the program and we'll know everything. Is that what we're doing, Rishabh?
Sorry, kind of, but like it's basically just there's a difference between this asterisk, right? I'm not really that familiar with C++, but like this asterisk is conveying that it's supposed to be the memory address. Well, this is just like copying over the reference to the value to that point.
Okay, hey,
And
let's
that's the
do
main
something here. Okay, well, one sec. Okay, get to the line end of line 6 and hit enter. All right, you have to get over that habit, I think, because it'll be very hard for you to distinguish where the declarations are and the logic starts. Okay, because that's all right. Good. So don't collapse that space. Okay, don't collapse that space. Try not to do that. All right. So the first line, basically, everybody happy with the first line, which says this is an integer variable and its value is 4. Is everybody okay with that? We'll
Yeah,
go step by step, one line by one line. Okay. Second line. The second line says address of int var. That says int var is now 4, but I don't want 4. I want the address of int var, which is a place where int var is stored. That is a location. That is a room number. That address of int var returns a room number. Everybody okay with that? Okay.
Yeah.
Not return, that evaluates to that thing. The compiler says that is a place where I'm going to put int var. Right? It's not even decided by the runtime system. The compiler knows where it put int var. That's where it is. Bam. It is a room number. Everybody okay with that? Okay. So now memory pointer, we have a star before memory pointer. That star says it's a dereference operator. Dereference means star says what is on the right side is actually not a variable. Well, it is not an integer. It is the address. It is an address, which means that star says star. That star. Can everybody see my hand? Right, the star. Okay, it looks like a star. 5-pointed star. Okay, so star says star is an operator. 2 star 5 is 2 times 5. Right? Star has many meanings. Right? Overloaded operator. 2 plus 5. 2. Right? Star is an operator. In this context, it's a unary operator. It means take whatever is on the right, interpret that as a room number. Go to that room number. Open that room, fetch the contents, and take it and put it in the place of the star thing, right? So that is essentially what it means. Star something will be replaced by the contents of that thing. Yes or no? Is everybody okay with that? Takes a little while, right? Takes a little while. It took me like several days to just get my mind around that. Saying because you have very soon you're going to have star, right? And when you're absolutely comfortable with that, you'll know what a star means. A star to a star, right? But and it's really powerful. All of these things are powerful, right? And that's why it's really powerful. It's worth investing time, especially Python, Java programmers. It is worth investing the time to spend an extra few days just to totally get to grips with star, so that it's just part of your DNA. And then you don't start, and then you get really good at at squeezing cycles out. Not that these algorithms, any fancy algorithm out there, you don't really need C++ to do it, right? Technically, you can do all of that in Python, Java, any language, or even JavaScript. So, but I'm saying that when it comes time to squeezing all the last cycles out of things and doing things, because eventually, no matter how fancy your languages get to suit some tailor-made domain-specific task, there will always be a need in every single domain in the last mile to get it as fast as possible, right? And nobody wants to do everything in assembler or machine code, right? Unless you're John von Neumann, right? So everyone wants a good intermediary, and which something like the WEBL of Don Knuth, right? Some language which is not totally machine language, but it's not like these other languages lack the power of C++. So C and C++, ideal, perfect, because it is a language which is like human readable. We can look at it and know what's going on. At the same time, as fast. We're not even saying there's this overhead. With Java, Python, everything, there's a small overhead, right? C++ as fast as machine code. Exactly the same, right? So it's so cool. Very rarely, some things, device drivers, you need to go to actual machine code, right? And even then, people try and make it so small, right? So they don't have to live in there. So C and C++ are so powerful. So if you're a Python programmer and say, I want to learn C++, it's very easy to learn C++, right? But what do you learn? If you say, well, I know the syntax of C++, and I know Python, so I know C++, right? Then it's our loss, because we know C++ because I can work with it. But ultimately, in the C++ toolbox, which has got like 3 tiers, right? The first tier is ordinary tools, like the tools that are available to everyone, like Python programmers, Java programmers, JavaScript programmers. Those are the tools on the top shelf, right? And then underneath, you have C++ specific tools like pointers and indirection and things like that under here. Technically, you don't need to go under here. Anything you can solve in the top layer, because you can use other languages. You can use exactly the same features here and solve everything. Now, so there is no use really in saying that, I know these languages, but I want to learn C++ and only learning the top, no use. It's the same as learning this other language. So when you say, I know these other languages, I want to learn C++, your investment in learning the language is different from someone who is investing themselves in learning the language, not knowing Python, right? If someone comes to learn C++, not knowing any programming at all, their focus on the learning, the pedagogical style that they should approach C++ is different, right? So you are not looking at learning the top layer, because the top layer of C++ to an existing programmer is like, 10 days worth of work. Yeah. Right? So those programmers need to focus the most of their energy on getting rid of the top layer as soon as possible and spending 90% of their time in level 2 and level 3, which is not even visible to other programmers. Right? So saying, where can I really use the power of C++? What are the places where I cannot use Python? Right? That's where I need to use C++. We can't say I'm going to do everything in C++. No. Right? So and that is where so that's where pointers are so cool and useful. And we can spend week 12 we can come back and play more with pointers, right? I don't care. And there's so many things we can do with pointers, and it's so fun, right? So sneakily change. So here what we're going to do is we started talking about star, right? Indent in and say star memory address equals some other value, right?
Memory pointer, right? Memory pointer or memory address?
Memory address. Oh, what was memory pointer?
Yeah.
And you need star, right? You need star. Star says memory pointer itself is a room number. Star memory pointer is an integer. Is everybody okay with that so far? Memory pointer itself is a room number. It doesn't even know. That is the interesting thing about C++, and is really also the power of C++, is that memory pointer does not know what it's pointing to. It is going to be the same. Yes? And this is something that will hit you many months down the track, I think, right? When you start learning about virtual functions in C++ and so much more power, right? And because of the fact that a memory address is the same regardless of what it points to. Now, isn't that cool? Isn't that cool, right? Just like in Java, you can say anything out there is an object. Yes, but how many people say I'm going to use that power of Java in which everything is an object, right? And say object equals. No, we always say in Java when we program we use very specific objects, right? So, but in C++, we actually leverage the fact that everything out there has a pointer which is exactly the same. This is so cool, right? And we leverage that by saying that I can now have a vector, an array of objects that are all different objects, right? But I'm not going to store the actual objects here because they're all different sizes. An array can only have homogeneous objects, right? An array elements have all got to be the same size, yes or no? Right? If they're not the same size, then the main benefit of an array, which is indexing by arithmetic offset, is lost. Yes? Yeah. They all have to be the same size. Now, if I have an array of many different objects, I have a line, a rectangle, a circle, polygon, they're all different sizes, right? One has 3 numbers, one has 10 numbers, right? Different sizes. So they're all, but I need to have an array of all shapes, one array of all shapes, but all the shapes are different sizes. How can I do that? Right, well, you can do that in other languages also, right? Java, you can have interfaces and derived classes. But in C++, one of the nice ways of doing, in C even, right? Even before C++, nice ways of doing that is to take advantage of the fact that, hey, you know what? All these objects may be different, but the one thing they all have in common is that they all have an address, right? And the address is the same size, no matter whether it's a king or a peasant, right? They all live in a place which can be addressed by a zip code. Right, and the zip code is 5 digits, no matter what. So isn't that cool? Right, so the address is the same. All humans are the same inside, right? So the interfaces may be different, but so we say the address, and that is a power that we bring to bear. And saying that memory pointer is just an address, but we can put a star in front of it and say now go and look at the contents of memory pointer, bring it back, and look at the type of memory pointer is an integer. So whatever you brought back must be an integer, and give it to me as an integer. That's essentially what the power of that one line which you're going to type is. We say star memory pointer equals, on line 15, say instead of memory pointer, you say star memory pointer on line 15. The beginning, say star. Yeah, memory pointer equals, but put some other number there. Just say 9 or something, right? 9, right? Semicolon. Yeah, on the next, and blank line after that, blank line after that. Yeah, okay, now copy and paste your, actually, hey, one sec, Rishabh. Let's put all of your couts in 2-line chunks with blank lines between them so that it's all very clear that each one is a separate experiment, right? Yeah, put a blank line. No. Yeah, all right, so that's good. Yeah, great, excellent. So get into the habit. I think it'll be very useful of just splitting up all of your work. So when you write English essays, right? I'm pretty sure your English essay teacher says, put it in, that's a title, a paragraph break, and so on. It's actually easier, I find, to even write when we have blank lines, your essays and all, and helps you break up your thoughts. Okay, all right. Now, no, the pointer and the number changes, right? You can put, wait a sec. What's going on?
Yeah, I still have a question with the pointer.
One sec. Yeah, change that pointer to, and by the way, on line 14, you say the pointer is left arrow pointer. I think that's probably what Hao-Yuan is also trying to say. There is no variable called pointer. I don't think we defined a variable called pointer. Did we define a variable? Oh, we did.
Yeah, I did. This is just like, again, I'm like saying like this is just a way to like differentiate between copying the memory address and copying over the actual value.
Oh, I see. I would say, hey, Rishabh, I'm glad we picked that up. Try not to do that. It's very dangerous because what you've done there in line 6 is that you are declaring an integer variable called pointer. Yes or no? Right? It's a common mistake. Many people do that. An integer variable whose name is pointer. Yes?
Mm-hmm.
Now that is highly misleading. Yes? For you, even after you master pointers, you come back, it's a misleading name because your variable is actually of type integer. It's not a pointer.
Yeah, and also it will not copy over the actual reference. It only copy the value.
Yes. And again, it's a, if you want it to be a pointer, you can do what Hao-Yuan is suggesting, which is you can say int pointer equals ampersand int var, right? You can say no on the same line as line 6 on line 6. I think we can actually go back to what Rishabh was trying to type in then, right? Now everything ties into place for me, okay? And Rishabh can correct me if I'm wrong, okay? Now, int pointer equals, that's fine. Say address of int var. Instead of just int var, say address of int var, address of ampersand int var. Ampersand int var. Instead of just int var, say
in front of the int var, have the end sign.
Put the ampersand sign in front of the int var. Backspace, yeah, there you go. All right, there, ampersand. Okay, now that will keep Hao-Yuan happy, right? It's that's what you were trying to say, yes, Hao-Yuan?
Yeah.
Okay.
Wait,
right, so
no, that's not what I'm trying to do. Though.
Otherwise, it's wrong. If that's not what you're trying to do, then it's wrong. This what you have now is wrong.
Wait, I'm confused. Why would you want to copy? Wait, okay. So it's a primitive type, so no matter what you do, it shouldn't copy it over, right?
What is that line going to do? Tell me what that line is going to do. And then we'll try and, because I'm pretty sure other people also are thinking the same thing, but fortunately you have the screen so you can talk on behalf of everyone who has the same misunderstanding. What do you think that line is going to do?
That should just be copying over the value, right? Because it's
yes,
type.
Okay.
But then if it was like, for instance, let's just like, for sake of argument, right? If I was to make like a string or something, which isn't a primitive type, right? Then it should just copy over the reference itself, right?
No, in every case, forget about the hypothetical. Tell me what line number 6 does. What does line number 6
that just copies over the value, right?
It copies over the value from what to what?
From int var to pointer.
Okay, so what is the value of pointer after that line has finished executing?
4.
So what is the contents of memory location 4?
Say that again. Sorry.
So you say pointer equals 4. You said pointer equals 4. After that statement, pointer equals 4. Yes or no?
Yeah.
Okay. So what that means to a programmer is that I have a variable called pointer whose value is 4. Yes or no?
Yeah.
Okay. Now, if I have a variable called pointer, right? What does a programmer do? They would not take the value of the pointer. They would take the contents of the pointer. right? So what we want to do naturally is take the contents of that pointer. But what you had intended to do there was take the value 4, right, and assign it to an integer. Or if you wanted a pointer, you want to take the place where 4 is stored and assign it to pointer. You can take the integer and you can say Anand is equal to Anand's room number. You're right. So my room number is 4313. I think it's 4. I haven't been to my room in such a long time. I don't know. Somewhere. Let's assume it's 4313. Okay. It actually was Rose's room before. 4300 building, right? 4413, 4400, right? So my room number is 4400. Okay, on 40. So I can say mine. I'm not 4400. My room number is 4400. Yes. So you cannot say that some room number is equal to me. You can say some room number is equal to that room number address. Yes. All right. So you have a variable. The name of the variable is room number. Yes. Pointer means room number. I want everybody to be on the same step, and you should nod on behalf of everybody. Okay. So tell me if you're on the same page. When you say I have a variable pointer, that means to me that I have a room number called pointer. So that variable name indicates a room number, not the raw variable itself. Yes or no? It takes a long time. That's what I mean, right? That's what I mean. It takes a long time to get to grips with pointers, and it's perfectly fine. But I'd like some feedback so I can basically keep nudging you guys in the right direction. Pointer as a name of a variable means a room number, not the actual variable. Yes or no?
Yeah, that's just a reference to it, right?
No, it's not a. You don't call it a reference. I think again, that's loose notation. Reference has a very different meaning in C++. Okay, don't call it a reference. What that means is a pointer is the address of. It's not a reference to, right? And again, that's another common mistake that lots of people say. Are confused by in C++ is saying, well, the reference of uses the ampersand operator, and then the address of uses the ampersand. They're all related. They're all the same. There are very subtle differences. And then this loose terminology gets more confusion in the place, and everybody is lost at the end, right? So don't use the word reference for now. Okay, references are different. Hey, Rishabh disappeared. Okay, I want everybody to be on the same page here, right? Pointer is the location, not the value. Is everybody okay so far?
Yeah.
Okay, great. So now when we say memory pointer equals 9, that is wrong, right? Because we don't want to say memory pointer equals 9. What we want to do is behind the scenes secretly change the value of int var. But we don't know the value of int var, but we know the room where it lives, which is memory pointer. So we want to say contents of that room equals 9. Yes or no?
Yeah.
Okay, so that's what we want to do. And contents of the room. There is a syntax in C++ to get the contents of. What is the syntax for get contents of?
Get contents of?
Yeah.
It's a star.
Star, thank you, Hawayan. Okay, so what we want to do is say star memory address equals 9, not memory address equals 9. Yes or no?
Yeah.
Okay, so when we say star memory address equals 9, and then we print out int var, you'll see that even though you didn't assign anything to int var, it's changed from 4 to 9. Okay, so that's a very simple experiment, right? And I wanted to try that because it actually illustrates the power of pointers. That means now you know, right? Which nobody else outside of C++, they don't suspect, right? Now you know that you have this power, this invisible power that lets you go and change something without having access to the object itself. Are we like totally in awe of this power that C++ confers upon us, right? We now have the power. That is why it's coming at the end of CS2A, right? It's really, with real power comes great responsibility to it, right? Because with this power, you can go around and screw around, right? You can change things around. And that's what happens also, right? In CS2B, one of the very first few assignments, you'll find yourself really now with the power of pointers behind you, you're going to go around and change pointers. And very soon you'll find that this incredible power, you'll be shooting holes all over. You're shooting yourself in the foot and you'll get bitten. you'll get bitten, and it's good to get bitten, right? It's good to get bitten by lots and lots of ants instead of a few snakes, right? So you'll get bitten, and it's fun, right? And when you have the power of pointers, you can go and change things without having access to the access to the thing, right? And which is both a blessing and a curse, and that is what the C++. If going back to the philosophy of C++ and everything, right, the whole power of C++ is meant to conceal all of that away from you, right? Was meant to take the power of C away from you so that people don't shoot themselves in the foot. That is basically the idea behind C++, right? A lot of the power of C is hidden away. And here are pointers, the real raw power of C++, C, and it's being exposed by C++. But it's coming at the end, because by the time you get to pointers, you already know, right? By playing around with the other structures, you know that you can't do anything silly, because you get into serious problems after that. And so that is why pointers is at the very end. Now, you know you have the power to go and change things, right? Now, even though if you know that value and you just publish that value, right? You're not publishing the value of int address, you're publishing the address of that, right? Now, someone else out there and say, hey, that's the address where int var is stored. I can go and change it, right? Now go and see out the int var is and print it out. You should get, yeah, there you go. Actually,
Yeah, the int var is 9.
It's 9. Yes. Now you see, you didn't assign anything to int var. Now, now do it the other way around, and you'll see that assign a new and you say int var. What happened?
Sorry.
Yeah. Now what you can do is change the value of the pointer, right? Change the value of the pointer, but you'll see that the int var doesn't change, right? Because that memory address, all these experiments I'll leave to you. You can play around with this code. Now what we'll do is take that one more step, right? Now let's create
an array.
Yeah, let's create an array. I was thinking we don't even need an array. What time is it now, right? Depending on the time, we'll do an array or just a plain variable.
Yeah, I mean, what do you mean about the copy value is? The line 21.
Oh, copy value.
The copy value is still 4. Because
yes, the copy value should be 4.
Yeah,
the copy value should be 4.
That's just for like my own notes. It's not
the name is
that's just good to know anyways.
The number isn't changing because there's no point.
I'm sorry. So I think line 20 should print 9. Is line 20 printing 9?
Yeah, line 20 is.
Yeah.
And then line 21 should print 4. Yes.
Yep. That's
what.
Yeah. How I am good with that.
Yeah. Good.
All right. Great. So what we want to do, Rishabh, is let's create an array. Create an array of, let's say, 2 integers. Just create an array of 2 integers, right? Array.
Sorry, I'm just playing like.
Yeah. Actually, save yourself the time. Hey, Rishabh, save yourself the time. Get rid of the comment and all, because we should all get into the habit of just looking at the code and knowing what it is, instead of depending on these comments. Because you should reserve the comments for something that really, really deserves a comment. These things we'll just get used to it. I'm just call it anything you want, int array or array, and call it, and give it 2 elements, size 2. I think, 2. Yeah. All right, great. Now let's go to the end and say now let's make our memory address equal to the array name itself, right? Let's say memory pointer equals ARR. Memory pointer equals ARR. I think you gotta, is there a spelling error? MEMORY. Oh, there's a star there. Yeah, it's funny, isn't it? I saw the first thing and I thought, oh, that's longer than this. Maybe this typo here. And I looked at it. No, the star is missing. That's why it's all right.
Wait, why is this not?
No, you don't need an address there. Just say AR. That's and I say that because it is something very specific to C++ and C, right? When anytime you refer to an array by name, and again, it is not obvious, and it is something that you just have to get used to, right? It's part of a design decision. In C and C++, and you can make a note of this. We can make a note of this. This is actually very important, right? Because I don't think it's even in a textbook. Or maybe it is, right? In C and C++, the name of an array means the same as the address of the first element, right? Oh yeah, you can make a comment saying in C++, in C and C++, the name of an array is the address of the first element. In C and C++, in C and C++. Yeah, actually, yeah. Hey, type this in, and this is I think this will be a good practice to when you're typing comments and also in programs. It is useful to try and make the comments as use as many abbreviations as possible, because comments are not, shouldn't be like a right. So type this in C, comma C++, all these shortcuts. You can also be ungrammatical in comments, right? In C, comma C++. Just get rid of everything. I'll type. I'll speak it out, and then you can rephrase it according to your taste. Okay. Get rid of C, comma C++. C, comma C++. Yeah. Yeah. C++. Yeah. The name of an array equals name of array equals. Yeah. Address of element. Address of first element. Address of first element. Okay. All right. So that keeps the entire comment within 80 columns and all. So that's kind of cool. All right. Enter. Okay. Now you can print out assign values to the two elements in the array. Say the first array of 0 equals 100 and array of 1 equals. You can actually put it on the same line. I'll show you how to put it on the same line. Before the semicolon on line 7, you say equals. On the same line on line 7, and before the semicolon say equals.
Yeah, but okay.
Yeah, well, I will try and do it on the same line. So one more way of doing it, right? No, you don't need comma, array 1 equals, and so on, right? This is you can actually say get rid of the whole thing, right? Get rid of all of that. Just say array of 2 equals array of 2. Get rid of all of that. No, all of that, everything you type except the first, everything in array of 2. Get everything that you typed just now. Get rid of it. No, not the whole line. That line was there. That's what I said. Okay. Yeah, if you do it a little slowly, I think we can save a lot of time. All right. So yeah, get rid of everything up to the comma.
Okay.
Get rid of it. Okay. Get rid of the comma also. Okay. Now put a space and then an equals. No. Hey, just a little slowly, Rishabh, and then we'll actually get it all done really quickly. Okay. Yeah. Space. No. Get rid of the semicolon. Get rid of the semicolon. Right. Space. And an equals. Okay, space and then a brace, space and then a brace.
I can't hear you. He keeps on talking in the middle of it.
Oh, so my voice is breaking up?
No. Some other person was talking in the middle of it. I just got broken up on my end.
I'm sorry. Yeah. Okay. All right. So say brace, left brace. Yeah. Okay. Space. 100, 200. Okay. And I don't even know if this is going to work, but this is what I was trying to get to. All right. And then semicolon at the end. Now, this is the way of just initializing an array like that. And it saves a lot of typing, right? Because the other way was also, Rishabh was trying to do it the other way. That's also possible. Some people do it. This is on the next line. You can say that equals. Yeah. And then we'll do a copy. This is actually an easier way to do an array. So now memory pointer equals array. Now print the memory pointer and also print the contents, right? And copy, memory pointer equals. Memory pointer equals. You just say memory pointer equals. Yeah, triple click that. Triple click. Yeah. Paste it there. All right. Yeah, when you paste it from column 0, indentation will be okay. All right. Now just don't say store at memory location. You say memory location, memory pointer equals, because we now know that it's the variable, right? Memory underscore pointer equals. Yeah, equals. All right. Right. Yeah. Okay. All right. And then copy those 2 lines and put the 2 lines again. The 2 lines. Copy both of those lines and paste them back again. Yeah. Triple click on the first line and drag it down. Yeah. Triple click on the first line, drag it down. Triple click.
I have no idea what is the first line.
Oh, I'm so sorry. Triple click on 23. Triple click on 23 and drag down one. Triple click on drag down 1. So that both lines. No. You have triple click and drag. So you get 2 lines. Triple click and drag, you get 2 lines in the selection. I get 3 lines. Triple click there. Triple click and all right. Okay. Copy. And then paste that entire block after a blank line. Paste that one blank line and then paste it one more time. All right. Now adjust the indentation. All right. Now you want to say, in fact, you don't want the first line. I'm sorry. You don't want the first. Get rid of line. No. I'm sorry. right? Get rid of line 26. Get rid of line 26. Yeah. I think I made this point last class and you weren't here, Rishabh. So I think it's worth making again. I think I made this point to either Chanyi or Turkey. Clicking and dragging, right? This is clicking and dragging an IDE motion that many people seem to be comfortable with, right? I urge you very strongly, all of you, to get rid of that habit, okay? Get into the habit of triple clicking, because clicking and dragging, you will realize very soon, is a huge hurdle when you're programming. Because when you're clicking and dragging, you have to detach yourself from the logic and you have to focus on, okay, have I got to the right place? Your mouse, right? Control. Triple click is, you can mindlessly do it. Bam, bam, bam. Okay. And so that is, it'll save you enormous numbers of hours. All right. All right. So now change that memory pointer equals to array of 1 equals, array of 1 equals. ARR square bracket 1 equals, and then print out the first element. Print out the first element. Yeah, print out the first element. And you say array. No, now it's 0, right? First element is at 0. Hey, I was waiting for you to type it in, right? Because other language programmers always say 1 sometimes there. Okay. So all right, good. All right. I think that's it, right? Yeah, okay, you can print both. You can print both. That's fine. Print both. Right, now run it, and you should and tell me if you all see the expected output. And then we want to make one more change here, and I think we have time for that, right? We want to make one more change, which will also now there are 3 or 4 concepts that were introduced in the process of this small program that Rishabh and I wrote, right? I don't know, this is 30 lines. There are 3 or 4 concepts that are very, very deep and important concepts that we've only scratched the surface of. And I don't want to go into the depths and details of every one of these and show you, but these are basically the starting points for your own experiments. Now, each one of those is an entire tree of experiments that you can carry on. So what I want to leave you with at the end of this class, we'll come back next class and implement a linked list and a stack and all those things. Of course, we're going to do that. But from today until Thursday, I would like everyone to experiment with each one of those pairs of lines. There's a whole bunch of family of experiments you can try. And if you try this by saying, okay, I want to increment by 1 and change it, well, what happens, right? All these things you should try and this scope for endless experiment and get utterly comfortable with this, right? And seek out these problems with use pointers. You have to force yourself to use pointers, because otherwise you will solve everything without using pointers. And the tragedy is that it is possible to do that. All right. So and run it. So yeah, okay. So 100 and 200. Okay. Now go ahead and say memory pointer plus plus. Okay, this is change we're going to do. So memory pointer plus on then plus memory pointer or memory pointer plus plus. Okay, memory pointer plus plus. Right now, just print the memory pointer itself. Just print the memory pointer and also the array. Right. In fact, copy the whole thing. Yeah. In fact, copy from 23 all the way up to 27 and put it there. 23 to 27. All those lines. You need all those lines.
Oh, all of them.
Oh yeah, 23 all the way up to 27. 20, triple click on 23 and drag down. Let's try this now. Triple click on 23. Don't pull up your index finger. Triple click on 23. Leave the index finger there. Okay. Now drag down 4 lines. Drag down 4 lines. Why is it not? Is this not the behavior in VS Code?
Oh, it's because it's using like the same kind of thing where like things that you're dragging this entire portion down. Here, I can do it.
No. It should not. No. That's one way of doing it. But this works in Xcode. Just triple click and drag, just triple click and without doing anything else, just triple click and drag.
Sure.
Wow. Okay. Xcode, you can triple click and then you can start block selecting from there. All right, cool. All right, maybe that's what you got to get used to here. All right, now copy those 4 or 5 lines. Copy all those 5 lines below.
Yeah, it's already been copied.
Oh, you have. Okay. All right. Now let's distinguish it. Memory pointer on line 31. Say memory pointer after plus plus. Memory pointer after plus plus. Memory pointer after plus plus. Great. Hey, David said something. Wait one sec. Oh, there's a lot of stuff in chat. Wow. Yeah. Okay. Great. Oh, Elizabeth had to go. Oh, is it time already? B, G, and G. Okay. All right. We're almost done anyway. Right? If you run it now, I just want to make 1 point, okay? 1 point, and that is something for you to just noodle over for a couple of hours. You got to think about this for a couple of hours and think about why are they doing it this way? Why not do it the other way? That's the important. You have to ask yourself, why are you doing, right? Now you see, I mean, actually increase the size, I got to drop, some of you have got to drop off the screen now. Okay, so what's the first value? Right, the first value of memory pointer is some number in hexadecimal. Yes? A 37A8540A8.
It's the same thing.
No, it can't be the same thing. You added one to memory pointer, yes?
I can
You
write
added
one.
You added one to memory pointer and you're getting the same thing again?
Yep. I mean, like the memory address isn't changing, so.
But you're plus plus. You're putting a plus plus on the memory pointer.
Mhm.
You're incrementing the memory pointer, right?
Yep.
So it should point to the next. It's not changing at all. Why is it not changing at all? 931540.
Try removing line 30. It should change.
Oh, yeah, that's probably the reason.
Oh, I see. Yeah, you incremented it and then why? Because we copied and pasted.
Wait, but then why is it increasing by 4 now?
Yeah, okay, that's your question. Okay, that's the question I wanted to leave you guys with. Okay, all right. How about Rishabh? Maybe, all right? Maybe, yeah, Rishabh can do it because he seems fairly comfortable with this. If not, well, maybe more than you, right? More people, as many of you as possible. Find out why it's incrementing by 4 and the plus plus is not incrementing by 1, because we are expecting plus plus to increment by 1. Yes. Plus plus should be
because it's just moving to the next memory address. That's
okay.
That's going to the next available.
So when plus plus, this is incredible, isn't it? See, plus plus has two meanings. If it is applied to a normal object, an integer, right? C++ knows integer should be incremented by 1. But if it is applied to a pointer, C++ knows that the pointer should be incremented by the size of the pointer, not by 1. Because it makes no sense, right? If you have an object of 10 bytes, if you just increment the pointer by 1 byte, you're not pointing at objects anymore. Yeah.
So on my computer, it might do something completely different.
Yes.
Wait, so is it going to the next available memory address, or is it just?
It's going to the next. No, it is going to the next, not to the next memory available memory address. It is going to the next integer in the array. In other words, it is basically moving. It is moving by the size of that pointer. It is moving by whatever that pointer is pointing to. The first was the room number, right? When you increment that, it goes to the next room. It doesn't go to the next person in the same room. So it moves the size of the room.
So, like, for example, if you were like pointing to like an array of 2 people, then it would.
No, forget about arrays. No, no. That's why I said arrays are different. That's why you got to do a little bit of research. I'm talking about, arrays are not objects. Only talking about objects and primitives. So objects and primitives means not even strings. Okay, we talk about integers, booleans, individual characters, and also objects you create like team, game, team player. All of those are objects, entire objects. An object might have 55 bytes in it, right? Who knows? You can have objects of any kind, right? It's a collection, a bag. Yes or no? So you can have things of different sizes. So try and do that as an experiment. Create an array of 5 objects, and then when you increment, it should go, the plus plus on the pointer should increment by the size of the object, not by 1, right? So that by itself is powerful. And the fact that arrays automatically, the name of the array is the address of the first element, that's a subtle powerfulness there, power right there. But tying the two together, it goes an order of magnitude more power. And the only way you can take these powerful things and put them together is to start not fearing the powerful things. Because, if you have a nuclear bomb here and a nuclear bomb there, right? And you say, oh, I can take this nuclear bomb and convert it into a power, a reactor and make energy, useful energy, right? I can make more energy with 2 of those. Unless you get, totally comfortable and with this, you're not going to try and mix the 2, right? Otherwise, you can create a world-class explosion, right? So you say, demystify pointers first, right? And then demystify the fact that arrays are the same as a name, the location of the first, right? And then you uncover many little powerful nuggets like this. And when each of those has become brain dead powerful and easy for you, right? Simple. Then you start putting the two together. And when you put the two powerful things together, you don't get 2x, you get 2 to the x, that much more power. And that's the next level, right? That's the next level. And it's incredible. The amount of things you can do with these things is just totally mind blowing. Yeah.
Is this also how you can change the source code of Windows by accident?
No, you can't change source code. Once you've written the source code and it's compiled, the source code is frozen, right? But what you're saying is that no. But what you are saying, Mark, is that it's not source code, but is this how you can change the program itself, the running program, the machine code? Yeah. Yes, that is how. So if you can somehow. But it's very hard. It is really, really hard. No, it is really hard because everything is possible. Everything is possible. If you want to go and basically assassinate some super duper powerful figure in the world, even that's possible. It's just that so the odds are so slim, right? It's very hard to do that. So even here, you can go and inject some malicious code into a machine in the Pentagon, right? But in order to do that, you need to know so many things that are practically impossible to know. You need to know exactly where the operating system was booted into memory, right? What the address, and you may know what segment it is and so on. You need to know a lot of these details, and then you need to engineer that into the RNA of your virus, right? So that when your virus eventually gets in, it knows exactly where to go and plant itself, right? And that location may also change because maybe the computer got rebooted and the entire operating system got loaded elsewhere in memory. So, but it needs to react. So the virus can be a dead virus that says with no intelligence at all and says, I'm just going to go in and bam into that location, not going to work. So it needs to go in and first, without making itself known, it has to surveil and find out and look for telltale signs of the operating system and log files and so on and so forth. And it does that for some many milliseconds, right? It does all this and says, okay, well, based on all of the information I've gathered, this is probably where the operating system is. That's where the kernel is. And based on my maps, internal maps of where the kernel is, this is where the critical device driver code is, which is going to read that signal coming in from rover from Mars. Okay. So, and then you make these guesses, right? Because you paid off these people from NASA to tell you the operating system of rover, okay? So they tell you, and you say, okay, well, that signal is coming in from Mars right now because there was a sunspot, which happened like 10 seconds ago, right? Now I'm going to intercept that and change those 4 bytes in that memory location, right? And then I'll change the history of the entire world from that point onwards, right? So it's possible, but the odds of that happening are so infinitesimally small. But that's how you do it, right? So now when you change, now you can say, you can do what Mark says, right? You can do something even more dangerous than say, I'm just going to change the value, right? I'm going to change the number from 2 to 5 because instead of launching 5 missiles into that country, I want to launch 10 missiles, right? Change the number from 5 to 10 because I'm the enemy of that country. Right? Maybe you can do that. Or someone could say, I'm going to change the source code, right? I'm going to go into that machine and say, well, they're just launching ordinary missiles. I'm going to change the logic and say, don't launch missiles, just go and wipe out the country, right? So you hardwire the logic and change the logic itself. And you can change the program because at the end of the day, the computer cannot tell. The computer cannot tell the difference between programs and data, which is one of the fundamental insights of programming, is to say that is what allows us to store programs just like data on a disk. Our programs are basically on a floppy disk and on memory sticks, right? The programs, they're static stuff. They're dead, like in a coffin, right? After you plug it in and give it that juice of life called electricity, right? Then your program just vivifies like that, right? It comes alive. That's when it does its magic. Until then, it's dead. So, and the fact that it's there on disk and not alive, and it's only when your program runs, it comes into being, right there, and it goes anywhere there's free space, it goes and lives until it lives, and it dies, and then goes back to disk until it's fired up again, another location, different context, different data, but it's the same program. It's the same program behaving in completely different ways based on the environment and the input it got. But it's the same program. So if you know the core detail of the program and you know how it's working, and you know that certain modules are always loaded at a certain offset from the first byte from main, right? Then you know how to hijack the program and make it do your logic instead of that logic. but the CPU itself has no way of telling what logic it's running, or whether even this is logic or data. No way of telling. That's the magic that allows us to write these programs that can just proliferate, right? So if you go to a tree, an oak tree, right, produces trillions and trillions of these chestnuts, and each chestnut has an entire program to construct a completely new oak tree from scratch. And this is the magic that allows that to happen, is that it doesn't matter. Most of these details don't matter. The overarching logic, if I've got the logic, I can just stamp out, bam, 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 like that, you know. And many of this, I even built fault checking tolerance, right? So that if something looks like it's dangerous, it's got a virus in it, I won't let it replicate. I'll kill it right there, bam. You can build all of that in. And then once you've got the basic stuff worked out, all you need to say is, now, all right, I've taken care of everything. All I need to do now is basically just replicate. And you start an oak tree, and it's a trillion copies, bam. I don't care if many of these copies are not even going to make it, right? If one or two make it, if more than one makes it, you've got exponential growth, right? So you got an oak tree, and it's producing trillions of seeds, right? But it still doesn't. The way to take up the world exponentially is to basically say, all I need is just the odds of more than one seed surviving, right? Because one becomes two, two becomes four, and so on. So on average, I just need one to become two. Then I can have exponential growth, right? And every single organism on Earth is doing a far more than that, right? It's compensating for incredible kinds of redundancy, solar disasters, right? You know, so Betelgeuse beam wiping out 99% of the Earth's population, right? Even then, life has got fail-safe redundancies built into it, right? One gene is enough, right? It'll just do exponential replication after that. So that's the beauty of, you know, pointers and relocatable code and all that. So we're just getting there, and we'll know, right? And then we write a few programs like that, you know how to replicate these things instantly. And then you go and you play, you know, you write a program in Unreal, write a game, and then you know, right? So Fortnite, and this is like thousands of players playing, right? And all the players are replicated instantly, almost instantly. Right? Every player sees a almost a real-time replica of all the other players on their screen, right? And it's all being replicated, bam, 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 like every micro movement is going, all of that. So replication is a key to.
Yeah, I just mentioned it because I remember stories from programmers talking about how C can mess with Windows entirely by accident.
Yeah, people can do that. Yeah, you just do it in assembler. With Windows, you can just open up a debug, debug, and you can write hex code right directly into the kernel. I don't even know if you need to be administrated to do that. Maybe you do from these days. Right. All right. Well, anyway, is it past time now? Elizabeth is gone, and wow, it's 10 o'clock. Oh, wow, it's right on time. Right on time. So I think we have one more lecture officially. Yeah. And then week 12. That's week 12. You can ask me questions about the final, not questions in the final, questions about the final and things like that. Or if you want to have some practice runs, some people want to come and code live and things like that, you should let me know. Give me a couple of days time so that I can think up some interesting projects to do in week 12. Maybe, you know, we can even take those projects and work on those over the summer break. If you're not doing an internship somewhere else, and if you have some time to kill and you want to pick up some skills on the side, I can possibly, you know, get some of you together and walk you through something, a simple project in Unreal or something, right? Build a game. And we can do some fun stuff there. Oh, this looks really nice. And I got this garden spinner at this dollar shop, and then I stuck it there. This is like a couple of days ago, really. And then when it spins, it casts this really nice shadow, and the shadow kind of starts when the shadow starts spinning when the wind blows, right? So yeah, you can see the. I don't know if you can see the spinner, but you can see the shadow start spinning right around that. Oh, there you go. Yeah. It's very nice. It's beautiful. Anyway, thank you all for your patience and sticking around. I had a great time. I think we did. We covered the essential parts of what I hope to do today, which is basically introducing pointers. And, you know, I would be really setting an unrealistic goal for myself if I thought that we could cover any more than what we did in pointers today, right? Because these three things, yeah, are enough to, wet your feet and start playing more. The only way you learn more about pointers is by using them, right? And that's the thing, just like math, okay? I know, and I've been a victim of this many times when I was a student, before a math exam, I basically read through the book. How many of you have done that? I don't know if I've mentioned this to you before. Before a math exam, I read through the math book. I say, oh, this proof. Oh yeah, this is important. This is important. Yeah, I know how to do this. Yeah, okay, it's all very simple. Okay, cool. And I go to the math exam like totally confident. Okay, and then I get a proof that I've actually seen and I know that I can do, but in the exam I don't do it. Right? I can't do it. I get stuck because there are some things that I didn't understand. But when I read through it, it seems very simple. And pointers are no different. Right? When you read code, it'll look like you understand it. Okay, it'll seem very simple and straightforward. And the only way to really understand pointers is to actually work with them. Right? Think that you actually have a project to do using pointers. That's why I say even if you can do it without pointers, try and find a problem that requires pointers to solve. Okay, or is using pointers to solve, because there's always ways to solve it without using pointers. Right? You got to find a way in which you can use these fine chiseling tools, right? Because otherwise nobody wants to use these fine tools and wear these big ass glasses and do that, right? People will say, okay, well, I'm just going to do this, bam, 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 like that. No, you got to find a reason to use these and do that repeatedly. Then you'll get to a stage where you can say, oh, yeah, give me any damn stone, I can get it to be as smooth as marble. All right. So, okay, good. Thank you so much for your time. I'd say we can have more classes if you want, but certainly I think it was a useful class. And play around with this more. I'm hoping to see some lively discussion in Reddit about pointers, about some experiments, about some extensions to these experiments. Right? Many times I don't see any discussion at all about what we're doing in class, and some people taking what we done to one more level, or some playing tweaks with it, right? Tweaking this. You should try all that and discuss that in the Reddit. That's what it's there for. Okay. Thank you all. Do you have any other questions? Anything else you want to ask, or are you good so far? And we'll get on Thursday. What we'll do is we'll implement a linked data structure using pointers. Okay, and implement a stack using that linked data structure. Okay, and I think that's it. Right, on week 12 next week, maybe we can do, if you want, especially Rishabh, I think it was you had some questions about quest 9 or something. I don't know, maybe someone did. Right, so maybe we can do a pointer example. It's very similar to quest 9 in class. Okay, in week 12. All right, thank you all so much for your patience, and I will see you on Thursday. Okay.
Sorry.
Yeah, Rishabh. Yes. Go ahead.
Yeah, sorry. I'm just waiting for everybody to leave.
Hey, Rishabh, thank you so much, by the way. Okay, I know it's really hard sometimes, especially sometimes with the audio cutting in and out, and also me constantly talking, and it's hard. So I think you did a fantastic job, and you were very, very patient, and responded to all the student comments also, right? Saying someone, I think Howie said do that, and you took care of those things. So thank you for doing all that.
Yeah, sorry. I just had to.
Oh, one sec. Turkey's still here. Hey, Turkey, are you good?